All right, so as you can see, I'm down here in the crawl space, and let's take a few minutes to talk about what makes this crawl space so awesome. And really, I mean, you're starting to clue into it now as you check out my backdrop here. We've got this really nice sealed vapor barrier. This goes throughout the whole place. It's all attached and sealed to all the vertical surfaces, and wherever two pieces come together, there's a nice piece of tape to connect it. We've got this nice shiny insulation on the foundation wall behind me. And what this all creates is what we call a conditioned crawl space. This is not your average crawl space, okay? Now, you've probably seen a lot of the normal kind. It's very common in our area for a crawl space to be vented. And what I mean by that is that it has vent openings in the foundation that allow outside air in and crawl space air out, and it's a vented crawl space. Those are going to have a cheap, usually black or translucent piece of plastic on the dirt. It's going to have fluffy insulation up in the floor system overhead, and that's going to be it. And if you have any experience with crawl spaces like that, you probably know how musty they can get, what an attractive place they become for pests like bugs and rodents, and just kind of generally how gross they end up being over time. Our company, Insulation Unlimited, has done a lot of business over the years for homeowners to go in and remove all of the floor insulation and ground plastic and just general junk that builds up in a crawl space, and try to replace it. And it's like, this company's older than I am, Insulation Unlimited is, and we've been in business long enough to have been back to, let's say, like, we insulated a house back when it was being built decades ago. We've been in business long enough to have done the house when it was built and come back to it, in some cases more than once, to the same house, to remove the floor insulation and put it all back, and come back years later and do the whole thing again. And after enough times of that, I started to think, there's got to be a better way. And that's when we discovered this whole concept of crawl space encapsulation. You may have heard of this. There's a whole bunch of new companies in the Chattanooga area whose sole mission is to encapsulate your crawl space. And there's a whole industry that's developed around it now, and for good reason. Like, they are fixing what I would classify as a widespread construction problem, and that problem is the vented crawl space. Why don't I like a vented crawl space? Well, for the reasons that I mentioned. Well, those vents, the purpose of them is to help the crawl space dry out, to keep it from like building up all of this moisture. But the fact is that in our climate zone, where we have so much humidity outside in the summertime, those vents are sometimes letting more humidity into the crawl space than they're letting out. And when it comes in, it's typically cooler in a crawl space than it is outdoors. It's kind of like a cave. And whenever you have a certain amount of humidity contained in some air, if you lower the temperature of that air, the relative humidity number goes up. Relative humidity is an expression of how much humidity air can contain relative to its temperature, because hot air can contain a lot more humidity than cold air can. So we bring hot, humid air into a cooler crawl space. There's the same amount of moisture in the air, but the temperature goes down. That's going to make relative humidity go up, because that colder air can't contain as much humidity as the hot air that it started as. When you have a certain amount of humidity at a surface, and particularly a mold supporting surface, you can get mold growth without liquid water present. That number is somewhere around 70%. So if you have a crawl space that has 70% relative humidity or more, you are at pretty high risk of growing mold, even if you don't have a water leak, okay? That doesn't make any sense, but that's kind of the natural outcome of building a vented crawl space. And then of course there's the pests and everything too. When we went to build this house, we knew that we wanted to get the mechanical system, the heat and air, inside the conditioned envelope of the house, and doing a conditioned crawl space made a lot of sense here because of the slope of the land and everything else. We were able to avoid doing a conditioned attic, which enabled us to keep a vented roof system, which is the most durable roof system that you can have. And that enabled us to do that in that way. So the way that we did it here, well, you can see, and actually I'll get to that in a moment, more about the benefits of a conditioned crawl space. Why was it important to us to put the mechanicals on the inside of conditioned space? Well, it's like this. Most duct systems leak. It's hard to get a duct system to be perfectly sealed, okay? You can have the best contractor with his best crew trying their best in the best possible conditions. It's hard to get it perfect, okay? And in fact, most of the duct systems that are installed in our area are really far from perfect from how well sealed they are. But you need them to be sealed because their whole job is to carry the air conditioning and deliver it to points that matter, right? Well, if it's leaky, it's not as effective in doing that, but there's another problem that goes along with leaky ducts as well, and that is what it does to the air pressures in a building. Now, when you have more air leaking out of the supply side of the system than you have leaking in from the return side of the system, you have an imbalanced pressure, right? The fan in this unit over here is very powerful. It moves a lot of air. And it's like pushing air on the supply side and it's sucking air on the return side. Well, the return is usually very short. In this case, it goes from here over to like a point that's maybe 16 feet that away. And that's it. It's just like the one tube. The supply side is usually very long. In this case, we have a trunk line that goes the entire length of the house, and then it's got all these branches that come off of it to feed all the different rooms. There's a lot of different joints and connections in the supply side that you don't have in the return side. Why am I saying all this? Well, every one of those joints and connections is an opportunity for leakage. And so the point that I'm trying to make here is that the supply side, 99% of the time, is going to be way leakier than the return side because there's more of it, and there's more opportunities for there to be leaks. And so what's going to happen is this. That fan is sucking air. It's sucking a certain amount of air out of the house when it's running. It's pushing an equal amount of air into the supply system. But that supply system is losing some air to leakage before it can make it into the rooms that it's being asked to supply. If this system is installed in an unconditioned zone, such as a vented crawl space or a vented attic, that leakage is going to put the building under suction because that air being sucked out of the building, the heat and air system is not giving back the same amount as it's taking, because some of that is leaking out on its way. Well, for every amount of difference between what it's taking and what it's giving, the building is put under suction and has to suck in some air from elsewhere to make up for it, to make up for the air that's being lost through the supply side. And that's going to happen through unsealed joints and penetrations in the building envelope. Well, that's a huge problem for energy. It's a huge problem for comfort. It can sometimes be a durability problem because of how you create the risk of their moving humid air across cold surfaces and creating condensation. And so duct leakage is a real issue because of how it creates a pressure imbalance inside the building and forces the building to suck air in from bad places, like the outdoors, like the attic, like a nasty crawl space. So if you contrast that to the crawl space that we have here, even if we were bringing air from the crawl space into the house, I'm way less concerned about that because of how clean it is down here and how controlled and sealed of an environment it is down here. But because this heat and air system occupies conditioned space, any duct leakage that we do have, and I think the guys that did this system did a pretty good job getting it sealed up, but any duct leakage that we do have isn't really a concern anymore. It may have a little bit of an impact on, how much air gets delivered to the room that it needs to be in, but it's not going to create those issues that it would if this were in an unconditioned space. So that's actually very important, and I hope I've done a good job of explaining that. I know it's complicated, but duct leakage really matters when your system is outside of the conditioned space, And that's why it was so important to us to bring it to the inside of conditioned space. The other thing that that does for us is it normalizes the conditions that the heat and air system is subject to. So we're not trying to heat the house using a unit that lives in a cold, drafty crawl space. We're not trying to air condition a house using a unit that lives in a stinking hot attic. This thing is subject to the same conditions as the living space is, and that's going to result in a few different things. Number one, way better efficiency, miles better efficiency. If the construction industry could do one thing, and if that one thing could just be getting the mechanical system to the inside of conditioned space, so many problems would be solved. And so much less energy would be consumed. That's why we like this here. The other thing is, this thing's going to stay cleaner because it's not in a gross place. The service tech that comes to work on this thing every year as part of your annual maintenance is going to be way happier and comfortable than he is at the place that he probably came from and the next place he's probably going, which means he might want to spend a little more time here. He might be in a better mood. He might do a little bit better job for you. You know, all of this translates into better equipment life, and that's just a huge win for, you know, durability and efficiency. And of course the air quality thing that we've been talking about this whole time too. You know, having this be such a clean and controlled environment is going to be a huge win for air quality up in the living space, because you're not living on top of a dank, musty cave. We talked about the way that air from this space, or at least from a vented crawl space, is going to get into the house. That's not going to happen here. And there's other reasons that I'll explain in the ventilation video why the air down here is going to stay separate from up there. But again, even if we did have air from in here getting up, the air that's getting there is way nicer than what you would get from the crawl space with all the dead raccoons in it, or whatever the case may be. You've seen the horror stories, I'm sure. So that's the conditioned crawl space. It consists of, like I said, this nice clean layer of white plastic that's all sealed and taped together. Beneath this layer is another layer of black 6mm plastic that we used as a temporary vapor barrier during construction. And then this white stuff on top is a 10mm, so it's 2 layers for a total of 16mm. That's not millimeter, that's mil, M-I-L, which stands for 1,000th of an inch. So that's a different unit of measurement than, 16 millimeters would be like, pretty thick. That's not this. This is 16 mils, okay? But again, it's all taped together. It's sealed. Wherever it meets the foundation wall, it runs up the foundation wall, and it's sealed and attached to that foundation wall with a really high quality tape. And then of course all the pieces are connected to each other with tape as well. The insulation behind me, you can learn more about in the insulation video as far as the unique properties and why we selected it. But that's a 2-inch thick piece of rigid styrofoam board that is sealed to the wall using an extremely high quality tape as well. And it's fastened to the wall using a washer head pin fastener to keep it there for the long haul. Now, something I need to talk about with the insulation on the foundation is termites. Okay, now, you may have heard some controversy over spray foam crawl spaces when it comes to termite inspectors. And we've taken the extra time to incorporate a detail here that's going to help with that. And I want to draw your attention to this top edge here. Now, when you get a termite inspection, what they want to see is this piece of wood here, the sill plate, and they want to see the first few inches of the foundation wall. Well, I want to have insulation against my foundation wall as much as I can, because anywhere there's not insulation, we have a bit of an energy penalty. But we also need to let the termite inspectors see what they need to see. So we have a cut in the back side of this insulation board that allows us to swivel that insulation down and out of the way. And forgive me, I'm disheveling a tape joint right here in order to show you this, but here's what I'm talking about. That swivels down and out of the way so that foundation is inspectable. And then when you're done, you just swivel it right back up into place and you're insulated again. We did that all the way around. And that's going to protect you for that termite inspection requirement. One last detail I want to point out in this crawl space, and I'm not sure if I'm going to be able to readily do so while holding the phone. But if you look, let's see, there's a couple of ducts hanging down, and that's on purpose. I can explain that in the ventilation video if you check that out. But if you look back there, and I'll see if I can get the camera to look back there, right there, that vertical pipe. That is a like a pre-staged, so to speak, radon collection pipe. If you've never heard of radon gas, that is a radioactive gas that emanates up from the soil wherever there may be an underground uranium deposit. It is the second leading cause of lung cancer in the United States. And well, I shouldn't say that. Some buildings are going to have that and some buildings aren't. There's a recommended action level from the EPA on if you measure radon content in your building above a certain amount, you need to, put in some kind of collection system so that you can evacuate it to the outdoors. Well, we don't know if there's radon here. We haven't measured for that. But if you do and you discover that you have enough that you want to do something about it, there's already a pipe here that is open to the dirt underneath the plastic. And the top end of that pipe is currently capped off up in the attic. And that's there just in case you need to install a radon mitigation system. The hard part's out of the way. The pipe travels up through an interior wall of the house, and it's sealed wherever there's a joint. And all you would need to do is extend that pipe through the roof, and you will probably be okay. Now, if you do so and you see that radon levels are still unacceptable, there are powered fans that you can buy. And you would just integrate one of those powered fans into that pipe, and now you're actively mechanically evacuating that soil gas from the house, and that should take care of you. But I just wanted to point that out because it's there. Okay, I think that is everything that needs to be said about the crawl space, and I hope you found this informative, and I hope you enjoy being down here with me. Now, there are, of course, other videos in this series that we hope that you check out that get into more detail on other aspects of some of the higher performing features that we've put into this house here. And we hope that you check those out as well. And yeah, thanks for watching.